Introduction. Okay, now what is switchgear? Alright, now switchgear is a kind of electrical equipment which refers to a complete set of power distribution device assembled from primary equipment and secondary equipment according to a certain circuit plan. It is used to control and protect circuit and equipment. It is an arrangement of electrical disconnect switches, circuit breakers, fuses, which are used to protect and control and also separate electrical device. Function. Alright, the switchgear is functioned to protect the equipment from short circuit and fault current. This device gives isolation to the circuit from power supplies. It increases the availability of the system by allowing more than one source to feed a load. The switchgear can open and close the electrical circuit under the condition of normal and abnormal. In normal condition, it can operate manually, so it ensures the safety of the operator and also proper electrical energy utilization. In abnormal conditions, it operates mechanically. Once a fault happens in this device detects the fault and detaches the damaged part in the power system, so it protects the power system from damage.
For low voltage switchgear, is designed to regulate up to 1 kV and commonly found in low voltage sides of power distribution transformer. While for medium voltage switchgear, it designed to regulate system from 3 kV and up to 36 kV. And it often found in systems that involving motors, feeding circuit, generator, transmission line, and distribution lines. Lastly, for high voltage switchgear, it used to control 36 kV and above because these switchgear are designed for high voltage usage and improve safety features. Then, this electrical circuit also reduce an exposure such as high voltage switchgear safeguard, controls, and isolated electrical device.
For the high voltage switchgear, this switchgear consists of 4 main compartments, which is the A, as we can see in the picture, is the bus bar compartment. B is the vacuum contractor compartment. C is the cable compartment, and D is the low voltage compartment. And this compartment also consists of several components in it. Alright, this as we can see from the side view, this high voltage switchgear consists of three parts, which is the oil, the withdrawal parts, and the copperwork and conductors part. As we can see in the picture, is the oil is the yellow, and the withdrawal part is the blue part, and the copper and conductors is the, we can see, is the red line or red pipe. In details, from the side view, we can see that the high voltage switchgear consists of many components such as the current transformer, circuit breaker isolating socket, circuit earthing plug, circuit breaker isolating plug, circuit sprout safety shutters, circuit breaker fixed contact, arc control chamber, moving contact crossbar, off position moving contact, truck that is removable, moving contacts, operating handles, operating mechanism, withdrawal handles, bus bar sprout safety shutters, self-aligning secondary plugs and sockets, bus bar earthing plug, instrument panel, bus bar chamber, voltage transformer high voltage fuses, voltage transformer secondary fuses, and current transformer. That's all. Thank you.
For the switchgear installation, there are 6 persons involved, which is first, project manager, second, construction manager, third, quality control engineer, fourth, site engineer, fifth, health safety and environment officer, and storekeeper. For the installation of the switchgear, there are 5 main steps. For the first step is the safety requirement. For the safety requirement, the project manager must ensure that there are only trained, authorized and licensed persons that can operate the power tools and do the testing job. Second, the project manager must ensure that all personnel dealing with the live electricity have been certified. Third, Wear a necessary PPE during the installation. 4. Have a safe lifting and shifting of the switchgear to identify hazard and risk. 5th, the project manager must ensure that the working area has provided with barricade, tape, safety net and warning sign. Then, before starting the installation, the permit of work must be obtained and applied. Lastly, emergency response plan procedure must be developed and established at the work site. Then, second, work sequence and methodology. For the work sequence and methodology, the quality control engineer must inspect all the material that have been delivered to the site and check if it's stored properly that has been recommended by the manufacturer. Second, the work needed to be carried out by the site staff under a strict supervision and guidance of the concern from supervisor, foreman and engineer. Then, the quality control engineer should coordinate with other contractor and arrange an inspection for the installation of switchgear to the consultant engineer. And the quality control engineer is responsible for all installation activities. And also, quality control engineer need to handle a material inspection request, which is MIR, for the inspection of the material that have been received at the site to the main contractor and consultant engineers. The third step is handling and storage. The material should be stored and covered and make sure the material are dry all the time. All the materials received at the site should be inspected and ensure that the materials are approved material submittal. Any discrepancy and damage found will be notified and reported for the further action to avoid any accident happen during the installation. The site engineer has to ensure that the high voltage panel that used at the site are free from any damage and or deformity of any kind. Any damage observed should be repaired immediately and properly. If the repair process couldn't be done properly, the high voltage panel that have been used at the site needed to be sent to the assembler for the rectification process.
Hi, my name is Safariah binti Mustafa. I will continue for the high voltage installation. Number 4 is general panel installation. Ensure that the work area is ready and safe to start the installation of panel. Ensure that installation of HV panel are carried out in accordance with manufacturer's installation recommendations. Refer to the approved shop drawings related to the area of installation and ensure that the required materials are available. Also, ensure that the materials are stored properly and there is no mark of damage. And next, ensure that the issued materials are approved according to the specification. Next is for the last part of HV installation. Is the installation procedure for switchgear panel. First, all required installation should be accordance to the applicable electrical regulations. All components should be verified against the approved material submitted. All installation should be carried out according to the approved shop drawing for the panels. Ensure that the floor surface is ready for base frames grouted on the open trenches inside the high voltage room. Minimum of clearance of 800 mm should be maintained at rear side of the panel so that easy access of termination of cables and other maintenance works can be carried out. A high voltage panel should be installed in accordance with the manufacturer's recommendations. Switchgear should be provided with proper earthing connections as per shop drawings and applicable regulation. Ensure that all cable entries and other openings of HV room, wall and floor are carried out with proper approved sealant. Upon completing the installation, ensure that all the works carried out as per local regulation. Raise WIR for installation of switchgear panel along with glending and termination for consultant approval. So now, for the conclusion, High voltage switchgear is any switchgear used to connect or disconnect a part of high voltage power system. This equipment is essential for the protection and safe operation without interruption of a high voltage power system, and is important because it is directly linked to the quality of the electricity supply. Electrical safety is also important because hazards such as arc flash and shock can result in death if you are exposed to them. Fortunately, the likelihood of this occurring is relatively low. However, the control measures that prevent this hazard require careful management, attention to detail, and technical competence.